Hello students, let us quickly solve all the multiple choice questions or short questions from GATE 2016. So from farm machinery and power. So generally there are 7 questions which are 1 marks. Some questions are having negative marks, some questions are not having. So let us then solve. First question from the farm machinery and power. It's I've given it 1. That's ASI or SI standard for tractor 3-point hitches has been categorized as category I to IV or 1 to 4 on the basis of choices of maximum driver power, maximum driver pull, brake power of tractor engine, maximum PTO power. So if you see the hitch points, there are 2 lower links, 1 upper links, okay, or upper hitch point you can say, or upper link on this one and lift arm. So you can just have a look at this, and as per the ASI standards there are 4 categories are there and there is also 0. So if you see the table, so the links specific sizes given, so lower hitch point and spacing, lower links, upper link, everything is in millimeters given. So these are the standards for everyone's use. So generally when the tractors make their models, they have to choose one of the specification from this table. So basically if you see, so the categories are basically according to the drawbar power. If you see less than 15 kilowatt, it's categorized as 0. Then according to 15 to 35 kilowatt 1, 30 to 75 kilowatt 2. These are the drawbar powers. So the correct answer for this will be the maximum drawbar power. So generally the 3-point hitches has been categorized as category 1 to 4 on the basis of maximum drawbar power. So this is the answer for the first question. Next question. So a force of 8 kN is applied perpendicularly to the axis of a crankpin having circular cross-sectional area. The allowable shear stress of the crankpin material is 40 Newton per millimeter square. If the crankpin fails under double shear, the design diameter of the crankpin in millimeter will be how much? So it's a straightforward question. You have to understand how the crankpin looks like and how the force is applied on the crankpin. Okay, so if you see, this is the crankshaft. Okay, if you see, this is the crankshaft. This is the crankshaft. Okay, so and this is the crankpin. So crankshaft is having on the bearing and is the housing. Okay, crankpin is having like this. So this is the crank radius from this to this. Okay, this is called the crank radius. Okay, and this is crankpin. So if you see, this crankpin will fail when a perpendicular load. This is the crankpin actually. This is the crankpin. So if you see a load is applied perpendicular to the crankpin axis, the load is 8 kN. Okay, so then it will fail due to double shear, because it will fail here or here. Okay, so these two sides it will fail. When it will due to shear failure it will happen. So the area of crankpin, if we take D the diameter of the crankpin, we have to find out. Then the area of the crankpin will be 5 pi by 4 D square. It's very simple. So if you see, there are 2 sides, so 2 shear failure will happen. So here and here. So if 2 shear failure will happen, then double shear of crankpin. So the total area will be how much? 2 into pi by 4 D square. So one side and another side, both are same. Therefore the area is 2 pi by 4 D square. Now total force applied is 8 kN. So that should be equal to allowable shear stress into shear area. So this is the shear area. So this is the shear area and allowable shear stress is given. So which is 40. This one, shear stress. Allowable shear stress is given, and this is the area. And total force applied is 8000 Newton or 8 kN. So if you equate with this one, very simple. So D square will be equal to 8000 into 4 divided 2 pi into 40. 40 is the shear stress is given. Therefore D will be this much, 11.284 millimeter. Diameter of the crankpin should be minimum this diameter so that it will not fail. This is the answer for this question. So the answer will be 11.284 millimeter. Next, A vertical rotor planter has 8 cells on each rotor. The rolling radius of the ground wheel is 200 mm. The ratio of RPM of the ground wheel to that of rotor shaft is 2:3. If the planting is done at a forward speed of 3.5 km/h, the plant spacing in the rows in millimeter will be how much? So you have to remember this. This is a very tricky thing. So the speed of the forward speed is given, but you have to be confident that the forward speed is of no use, because when any planter which is having ground wheel, if ground wheel is there, there is this is irrelevant of the spacing, because the plant spacing is it is asked, so it is not required here. So only the ground wheel is very important. So let us do. So this is the ground wheel, and this is connected to the rotor shaft. So the vertical rotor is here. Here is actually there will be 8 cells. Here it's shown its number of cells, but you just take it 8 cells here. These are one cell. Okay. Like this in the periphery there will be 8 cells. Okay. So if this ground wheel rotates 2, then this shaft will rotate 3 times. It's given 2:3. 2:3 it's given. So it's very simple. If it rotates 2, so if you see the rolling resistance radius is given this one. So rolling radius of this one given. So RPM on the ground wheel will be how much? The let it RPM is how much? Let it 2 in this case. Then pi into 2r. 2 pi r is the periphery. So this is perimeter. Okay. So when it rotates in 1 RPM, then it will move this much. Okay. Then that will be equal to, that should be equal to RPM of the vertical rotor, because there is a ratio 2:3 into number of cell into seat spacing. This you have to remember. This is very simple. Not formula, but this is a standard one. Okay. So if it rotates 1 time, 2 times, it will rotate 3 times. So in 2 times it will rotate 2 into perimeter. Okay. 2 into perimeter. You see, this is at perimeter. So 200 is given the rolling radius. So 2 actually instead of d I have written 2r. So this one, then there will be 3 times it will rotate, and it will give 8 cells or 8 sheets. So 3 into 8 sheets. So that means into seat spacing. So that should be equal to this. So from there actually you can find that seat spacing will be equal to 2 into taking this side. So it will be 104.719. Therefore the problem answer is 104.719 millimeter the seat spacing. Okay. Next, the effective temperature scale ET developed in 1972 on the basis of human model is heart rate. These are the choices given, but you have to see effective temperature is related to what? Temperature of the body is related to physiology of the body. So generally when thermal comfort happens, like you see that when the more temperature will be there, then we are sweating. So the physiologically the cells and the body behaves, so that this will be the answer. So physiological response will happen according to the change in temperature of the outside in basically the operators. Okay. So heart rate is not related to this temperature. Okay. Blood pressure is not related to temperature, and psychological response is not related to temperature. Only this is the related to temperature. So the answer will be physiological response. Next question. As per ASI standards, the diameter of 1000 RPM PTO shaft will be with 20 spline will be 30 mm, 35 mm, 40 mm and 45 mm. So let us see the table. It's for your information. Maybe later on you should know these things. So according to ASI standards, these are the classification: type 1, type 2 and type 3. Okay. This is type 1, this is type 2, this is type 3. If you see the nominal diameter, standard operating speed, these are the two things most important. Other things are their groups and everything. If you study it properly, then you can know. So basically the millimeter nominal diameter and RPM. According to RPM and speed, RPM and torque. So basically the nominal diameter is decided. So type 1 has 35 millimeter and according to the speed 5, 10, 40 plus minus 10. Splines will be 6. So in this case you see this is also type 2 35 mm, 1000. So here it will 21 spline. 21 spline. Here 6 spline. You should remember the 6 spline, 35 mm and 540 rpm. This is 21 spline, 35 mm and 1000 rpm. So here actually type 3 is 20 spline, 20 and 45 mm for 1000 rpm. So this is basically, if you see the powers will be more in this case. So the answer will be 45 mm. Next, in restraint link operation of 3-point hitches, the line of pull passes through virtual hitch point. Bending force exists on raw links above the virtual hitch point, below the virtual hitch point, through the virtual hitch point. So let us see that whether above or below or through. So if you see for the restraint link actually all the weight, everything comes from the tractor. There is no vertical support by this wheel. Actually you can see this is the gauge wheel. So this no support is taken from the gauge wheel. In this case, all the support of the implement is taken by the tractor. So in this case, if you see the line of pull point of resistance, so all the solid resistance meeting at one point. So this is the line of pull. So line of pull is this one. So this line of pull is above this virtual hitch point. You can see this is virtual hitch point. Okay. So you can analyze it properly if you compare with it is free link. So free link is like this. In free link actually all the load is taken by the implement. So you can see here the weight of the implement is acting here, but the G is here. Okay. So if you see that this line of pull it's resultant of this and this passes through virtual hitch point. Okay. So here you can see this is passing through these points. So this is the difference. So in this case, the answer will be above the virtual hitch point and bending force exists on the line. Definitely, bending force will be there because it is due to it try to compress. So the upper link, lower link will be having bending. It will try to bend. You can see. So if you analyze properly, so you can find out the answer. So you should remember this. This is very important one. Maybe next GATE may come also. So next is the last question from the multiple choice or small questions. That is, a gear pump discharges 100 liter per minute against a system pressure of 15 megapascal. The overall efficiency of the pump is 0.75. Input power to run the pump in kilowatt will be how much? It's a straightforward question. So it's a very simple one. Let us just calculate quickly. So output power of the pump we know. That is, let it P0. PO in kilowatt is discharge into pressure. How much discharge it is giving? So let it in meter cube per second, and pressure developing, let it is kilopascal. So if you see kilo is there for kilowatt and meter cube per second discharge into pascal, that is watt. As you know, meter cubes per second, if you see meter square, so meter Newton into meter per second. So then you can find out easily. So this is kilowatt. Okay. So now then the input power of the pump will be how much? So that is Pi should be equal to PO. That is output divided by overall efficiency. So PO is this much. This is already from here. Okay. So this is output power and how much this is input power to the pump. The input power only the overall efficiency you have to divide it. So that means you need more power because some losses are there. So clearly, so just putting the value, so pump discharge is given 100 liter per minute converted into meter cube per second because the unit is this much, meter per second kilopascal. The pressure is 15 megapascal, so it will be 15 to 20 kilopascal because it's in kilopascal, so you convert it to kilopascal. It is meter per second, you convert it to meter. Then you putting the values, the input power of the pump will be just put the value 100 into 10 to the minus 3 into 15 into 10 to the minus 3 divided by 60 because 60 was there per minute, was there, it's per second. So it's 0.75 was the overall efficiency given. So if you put, then you will get the answer, that is 33.33 kilometer. So input power to the pump will be 33.33. This is the answer. So this is all for GATE 2016. So goodbye.